Okay, so today's session is about inductance calculation. So let's first start this chapter and let's see how many of you have understood the inductance calculation topic. Okay, so I have taken some questions on inductance calculation and some questions are from short transmission line ABCD parameters. Okay, so these things I have taken. So let's start the session and let's start solving these questions. But first let me cover the introduction part. So this is my introduction. My name is Asu Jangra and I teach almost every subject in electrical engineering. You can start your preparation with me on BYJU'S exam prep. We are going to start this series because you know that GATE 2024 is organized by ISC Bangalore. So in this series we are taking GATE 2002 and 2008 and then 2016 questions, because in these years the questions or maybe the GATE exam is conducted by the ISC Bangalore. So we are taking these 3 years exam and we are going to solve these questions, and it is starting from 23rd of August. Okay, so this series is going to start from 23rd. There is one free workshop which will be on 20th of August. Okay, oh wait a minute, this is not about workshop, this is about scholarship test. Okay, so you have to give the scholarship test if you want to join BYJU'S. The thing is, you can get the scholarship if you appear in the scholarship test. So you have to appear for this test if you want scholarship, and you can get the scholarship up to 90%, and you can register for this scholarship test, guys. This test will be on 20th of August from 9 AM to 9 PM. Okay, so you can register for this test. There is a workshop, there is free workshop on 20th of August, and it will be taken by Rakesh Talleja sir, and the title of the workshop is Know All About Data Science and Artificial Intelligence for GATE 2024. Okay, so you can join this workshop and get the input. So again, you can register, the link is given in the description. This workshop will be on 20th August. Okay, so guys, let's start today's session. Okay, this is the first question on your screen. This is the first question on your screen, and I want you to solve this question. Tell me, guys, tell me what is the correct answer for this question. A composite conductor consists of 3 conductors of radius r. So it's a single conductor. It has 3, you can say it's a composite conductor. It has 3 strands, you can say. Okay, so there are 3 strands of the conductor. The conductors are arranged shown below. The geometric mean radius in centimeter I need to calculate of the composite conductor is kr. I need to get the value of k. What is the value of k, guys? What is this value k? Tell me what is the correct answer. It's a very simple question. You can solve it easily. So you have to calculate ZMR. You have to calculate ZMR. If you can calculate this ZMR, you can easily solve it. You can easily calculate this value of k. Tell me, guys. Tell me. I have taken some PYQs. Okay, these are previous year questions from GATE exams. So these questions are simple. Please tell me what is the correct answer, everyone, and don't forget to like this session. This question is very easy. You have 3 strands in a composite conductor. So there is a conductor. There are 3 strands in there. Now I need to calculate the ZMR in centimeter, and ZMR is k into this capital R. What is the value of this k? Okay, we need to calculate this value of k. Tell me, guys, how to calculate ZMR, geometric mean radius. So the geometric mean radius means self distance you have to write. Okay, so let's call it conductor 1, conductor 2 and conductor 3. So what I need to do is GMR will be equal to D11, D12, D13. Okay, D11, D12, D13. Okay, these distances I have written. Okay, this is for conductor 1. Now for conductor 2, what are the self distances? D21, D22, D23. And now for conductor 3, D31, D32, D33. Okay, and total 9 terms are there, so you have to take 9th root. But let me tell you, guys, let me tell you one interesting point. You can see that this D11, D22 and D33, they are same. D11 is equal to D22 is equal to D33. They are same, and that is equal to, its radius is R, so it will be 0.7788 R. They are same. So what you can do is you can neglect these values. I mean, only one time you write. Similarly, D12 and D21 are same, so you can neglect it. D13 and D31 are same, so you can neglect it. Because already you have written that, no? Already you have 13 and 31, so you have written it twice. So why to write it twice? Okay, so you can neglect it. I hope you got it. Okay, now it's time for D23. So you can see that this D23 and 32 are same, so you can again neglect it. Okay, or there is one more way. Don't neglect anything. Don't neglect anything. Okay. 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 Don't neglect anything. If you don't neglect, then also you can put these values and you can solve it. So let's solve it. Let's not neglect anything. Okay. Now what is this quantity? This is my GMR. So let's put these values. What is D11? D11 is 0.788 R. Okay. 0.7788 R. Okay. Now what is D12? D12 is 3 R. And what is D13? This is again 3 R. Now if you write these three terms will also be the same. These three terms will also be the same. So why to write all these terms? Only these terms are enough, and you can take the cube root. Because you are taking 9th root. What you are doing is you are repeating these things. I mean, whatever these bracket terms are, the same are available here, same are available here. So let's not write this and this. Only these three terms are enough. So what you can do is you can take this R outside, and it will become cube root of 0.7788 into 9. Okay, you can calculate this value R into cube root of this, and this will become my K. This will become my K. Okay, so you can calculate the K value, guys. What is the K values? Tell me, what is the K value? What is the K value? What is this K value? So you can calculate this K value, and I am assuming that this R is given in centimeter, though it's not mentioned. Okay, that this R is in centimeter, but anyway, so let's assume that this R is in centimeter. So you can calculate this K value, guys, and you will get the answer. I hope it is clear. This question was very simple. Let me even get the value also. If you want this value, let me get the value. So first 0.7788 into 9. Okay, so you will get 7. This quantity will become 7, and now you have to take cube root. Okay, cube root of 7. Let me take cube root of 7. Wait, 7, and then I have to take cube root. Oh, I don't know how to take. I mean, I don't have the calculator, so I'm doing in the mobile. So please tell me what is this value, guys. Please tell me what is this value. I don't know. This value came out to be 1.92. Okay, 1.9. Please check. 1.91. Okay, thank you, Vetri. 1.91. Okay, so this is the correct answer, guys. Let's come to the next question. The next question on your screen is this. The question says, consider overhead transmission line with 3-phase. Okay, 50 Hertz balance system with conductor located at the vertices of an equilateral triangle. So triangle is equilateral and each length is 1 meter. Okay, this is 1 meter, this is also 1 meter, this is also 1 meter. The resistance of the conductors are neglected. Okay, so conductor has only reactances. The geometric mean radius of each conductor is, GMR is given as 0.01 of each conductor. This is my GMR. Neglect the effect of the ground. The magnitude of the positive sequence reactance in ohm per kilometer. It means the reactance means, what is the meaning of reactance? Reactance means you need to calculate this value j omega L, okay, per kilometer. You calculate this inductance per kilometer length. You calculate the inductance per kilometer length and you multiply it with j omega, okay. Omega is 100 pi, okay, and that way you can calculate the reactance of the line, okay, series reactance of the line. Calculate this value, guys. Calculate this value. Do it fast. Let's see how many of you can solve it. Do it fast. It's simple question. Do it fast, everyone. I'm giving you some time also. Let me give the time also. Okay. Maybe 2 minutes, I think enough. Okay. Do it, guys. You have 2 minutes to solve this problem. It's easy. Do it fast, everyone. Do it fast, do it fast. Zero 0.305. Okay, Ashok, let's wait. Let's wait. Do it fast, everyone. Okay, guys, so time is over. Now it's my turn. Okay, we know that the inductance of a line is 2 into 10 raised to power minus 7 ln GMD over GMR. Okay, this is how you can calculate the inductance of a conductor, of a phase conductor A. Let's say A or B or C, whatever. Now the GMD is mutual distance, 1 into 1 into 1, and take the cube root, so it will be 1 again. So GMD is 1. 2 into 10 raised to power minus 7 ln 1 divided by GMR. GMR is given as 0.01. Okay, so this is my inductance. So it will become 2 into 10 raised to power minus 7 ln 100. This is Henry per meter, but I want Henry per kilometer. If you want Henry per kilometer, then you have to remove this 3 power. So it will become 2 into 10 raised to power minus 4 ln 100, and it will become Henry per kilometer. Okay, what you have done is you have removed 10 raised to power minus 3 from this. So this is Henry per kilometer. Now I want this reactance. So what you can do is you can multiply it with omega. Omega is 100 pi. So this will become 100 pi into this value, 2 into 10 raised to power minus 4 ln 100. Okay, you will get this. Okay, this is the reactance value, guys. Now you can calculate this value. Tell me what is the correct answer. Why not 0.7? Because already GMR is given, na? GMR is given. To calculate GMR, we use 0.7788R. but GMR is already given to us, 0.01. So directly we will put the GMR value. Okay guys, so what is this value? Can you calculate this value? What is this value? This is the answer. This is the answer we have. Okay, now I don't have calculator. Please calculate this value and that will be your answer. Okay, so it will be the reactance in ohm per kilometer. Per kilometer. Series reactance. Okay, let's come to the next question, guys. Let's come to the next question. And the next question on your screen is this. The next question on your screen is the conductor of a 10 kilometer long, so it's a short transmission line, single phase, 2-wire line is separated by a distance of 1 meter. Okay, it's a single phase line, so there are 2 conductors. Okay, and these 2 conductors are separated by 1.5 meter. Okay, the diameter of each conductor is 1 centimeter. It means the radius is half centimeter. The radius of each conductor is half centimeter. If the conductors are of copper, the inductance of the circuit is, it means I need L. This is A conductor, this is B conductor. So if you want to calculate inductance of the circuit, it will be LA plus LB. You need to find this value. Okay, so do it guys. Let me put the timing also. The time is, again, I'm giving you 2 minutes. Try to solve this question. Try to solve this question. Do it fast, everyone. It's a simple question again. It's a simple question. Do it fast. And tell me the previous question answer also. Do it fast. And don't forget to like this session, everyone. Everyone, please like this session. And you have 2 minutes to solve this problem. Do it fast, do it fast. Everyone, do it fast. What is the correct answer, everyone? Do it fast. It's a simple question again. Okay, time is over. Now it's my turn. So first let's calculate LA. We know that LA equal to LB. And that will be equal to 2 into 10 to the power minus 7 ln GMD over GMR. What is GMD? GMD is 1.5, mutual distance. What is GMR? GMR is 0.7788 into this R. R is 0.5 into 10 to the power minus 2. Okay. This is my inductance in Henry per meter. In Henry per meter. So I need to find the total inductance. It's not in per meter, you can see that. So obviously I need to multiply with 10 kilometers. So first let's calculate this in Henry per kilometer. What is the inductance value in Henry per kilometer? You can remove 10 to the power minus 3 from there. So it will be 2 into 10 to the power minus 4 ln. If I remove 10 to the power minus 3, then it will the left power is minus 4 ln. It will become 3 into 10 to the power 2 divided by, take this in the numerator and this can be cancelled with 3. 3 into 10 to the power 2 divided by 0.7788. Okay, and this will become Henry per kilometer. Okay, now for 10 kilometer I have to multiply with 10. So if you multiply with 10, the total inductance of one phase will be 2 into 10 to the power minus 3. Why minus 3? Because I have multiplied with 10. ln 300 divided by 0.7788 Henry. Okay, Henry for the entire phase. Now for the entire circuit you have to add LA plus LB. So you have to multiply it with 2 because LA and LB are same. So you have to multiply it with 2. So if you multiply it with 2, you will get 4 into 10 to the power minus 3 ln 300 divided by 0.7788. Is it clear, everyone? Okay, so you can calculate this value and tell me the correct answer. What is the correct answer, everyone? What is the correct answer? Please calculate. Why I have multiplied it with 2? Because LA and LB, there are two conductors, no? That's why. So I hope you understood it. This was again a simple question and you can solve it easily. Okay, so you can calculate this value and you will get the answer. Okay guys, let's come to the next question. Let's come to the next question, and the next question is this on your screen. I don't know, I don't have the calculator, so please calculate this value and check the correct answer. Check the correct answer. I don't have the calculator, so please calculate this value and check the answer. Let's come to the next question, guys. The next question on your screen is this. The generalized circuit constant of a 3-phase 220 kV rated voltage medium length transmission line. So ABCD parameter are given to you, A, D, B and C. Okay, it is given that if the load at the receiving end is 50 megawatt, at the receiving end the load rating is given as 50 megawatt. Okay, it is 50 megawatt at 220 kV. This voltage is 220 kV. Okay, with a power factor of 0.9. Power factor is given as 0.9 lagging. Then the magnitude of line to line sending end voltage. It means we need to find Vs. What is Vs? We need to find Vs. So I'm giving you some time. Let's take the time as maybe again 2 minutes. Okay, so I'm taking this time as 2 minutes. Okay guys, try to solve it. So the time is 2 minutes. Do it fast. Do it fast, everyone. Do it fast, and tell me the correct answer. It's a simple question again. The only thing is calculation you have to do. You have to do the calculation. Otherwise, the problem is very simple. Okay. Okay, so time is over. Now it's my turn. You can see that I need to find the sending end voltage. Receiving end voltage is given to us. Now we know that sending end voltage is equal to AVR plus BIR. We know this A, we know VR, we know B. If somehow we can calculate IR, receiving end current, then we can calculate Vs. It's easy peasy. Now IR can be calculated from this power. This is 3-phase power and this is the line voltage. Okay. So IR is a phase current. We know that this three-phase power, that is 50 into 10 raised to power 6, it has to be root 3 VL IL cos phi. Now from this relation you can calculate this line current. This line current will again be the phase current also. Line current and phase current will remain same. So at the receiving end, if you want to calculate this IR will be equal to 50 into 10 raised to power 6 divided by root 3 into VL. What is the line voltage? Line voltage is 220 kV. Okay, and what is the power factor? Power factor is given as 0.9. So you will get this IR. You'll get this IR. This is my IR, receiving end current. But IR has some phase also, no? It will have some phase also. So you can calculate this value. Please calculate this value. What is this value, guys? Let me calculate for you. Let me check what is this value. So I don't have calculator, so I'm using my phone. You can cancel this. This will be 10 raised to power 3. So it will be 50,000 divided by. So 50,000 divided by 220. Okay. And then divide by root 3. And then divide by 0.9. Okay, it came out to be 145.8. 145.8. I think my calculation is correct. So 145.8. Okay. So this is my receiving end current, but it has some angle, no? You can see that the power factor is 0.9 lagging. So what is the phase of this current? If you take this voltage at 0 degree, let's say, if the receiving end voltage is at 0 degree, then what will be the phase of this current? So it will be cos inverse of, so let me take the cos inverse of 0.9, and it came out to be 25.84. It means this current is lagging 25.84. So we have calculated the current. Now you can put it here. So sending end voltage will be equal to A. A is this 0.3936 at an angle of 0.98. This is A into this VR. But let's take it phase voltage. Let's take it phase voltage so that we can get the phase voltage of the sending end. So the phase voltage is 220 into 10 raised to power 3 divided by root 3 angle 0. This is the phase voltage I have taken, VR, plus B into IR, plus B. B is this, okay, 142 at an angle of 76.4 into IR. What is IR? This is the phase current, 145.8 at an angle of minus 25.84. Okay, so I have put this angle. Now you can calculate, this is the phase voltage at the sending end, and we require the line voltage. So what you can do is, whatever this answer you get, multiply by root 3. Multiply by root 3. So you have to use the calculator. You have to use the calculator to calculate this value, guys. Okay. So this way you can solve the problem. The concept was very easy. It's a very easy concept. Ultimately the calculation is there in the question. Otherwise the concept is very simple. Okay. Let's come to the next question, guys. The next question on your screen is a 220 kV, 20 kilometer long 3-phase transmission line. So we have a 3-phase transmission line. ABCD is given to us. This is A, 0.96 angle 3 degree, and this is our B, okay, and this is our C. C is 0.5 into 10 raised to power minus 4, angle 90, okay. The charging current, I need to find the charging current, and let me put the options also, because the options are missing. So let me check the options, and so that I can put the options as well. So we need to find the charging current, guys. 11 by root 3. In the B option, it is 11 root 3. In C option, it's 11, and in D option, 220 by root 3. Okay, tell me which option is correct. Okay, which option is correct? charging current per phase. Charging current per phase is required. Okay. Sir, problem on long transmission line. Yes, problem on long transmission line we will take. We'll take in upcoming session. Don't worry. We'll also take some problems on long transmission line. But right now, we are taking problems on line inductance and short transmission line or medium transmission line. Okay. So tell me guys, what is the correct answer for this question? I need to find the charging current. Let me give the time also. No? So time I'm providing again 2 minutes to solve this problem. Do it fast, everyone. Try to solve this problem. This is easy problem. Do it fast, everyone. And don't forget to like this session. Don't forget to like this session. Everyone, try to solve this problem. It's an easy problem. Okay guys, do it fast. Do it fast. Okay, now it's my turn. What do you mean by charging current? How to calculate the charging current? We know that Vs equal to AVR plus BIR. Is equal to CVR plus DIR. Okay, we know these relations. And if there is a transmission line, let's say, what do you mean by charging current? Charging current means if there is no load, let's say I don't connect any load, still the source has to supply the current. That current is known as the charging current. Okay? If there is no load, it means if there is no load, it means IR has to be 0. If I put IR to be 0 and then I calculate this IS, that IS will be known as charging current. Okay? So what I need to do is, first let's put IR to be 0. If you put IR to be 0, then you have to calculate this IS. Now how to calculate this IS? IS will be equal to this C into VR, and VR is Vs upon A. VR is Vs upon A. But remember, I need this phase current. So I need to get this voltage as phase voltage. So what is the sending end voltage? What is the sending end voltage? So sending end voltage has to be this. Okay. I have to take this as sending end voltage. Now tell me guys, if this is the sending end voltage, 220 into 10 raised to power 3 divided by root 3 you can take. And what is C? C upon A. C is given as this 0.5 into 10 raised to power minus 4 angle 90 divided by A. A is given as 0.96. 0.96 angle 3 degree. Okay. So we want only the magnitude. The magnitude is required. So you can see that this will become 22. If you take this power, this 0 will also go. Okay. 22 into 0.5, that is 11. So in the numerator you will have 11. In the denominator you have root 3 into 0.96. Okay. 11 upon root 3 into 0.96. This has to be the magnitude of the charging current. I think I have made a mistake. No, I think it's correct. So tell me what is the answer? What is the answer, guys? Please tell me what is this answer. Let me check first. Yes, these are the phase voltages. Okay. So everything is fine. Everything is fine. You can calculate this current like this. VR is Vs upon A, and Vs is 220 kV. So I'm taking this as line voltage. Okay, so 220 by root 3 is the phase voltage I have taken, and I have put these values, and then you can calculate from here. I think this is the answer, guys. So what is the answer? You can check. You can check the answer whether it is matching in the options or not. Please check it. Please check whether any option is so I hope you got it. I mean, the concept is very easy. The concept is very easy. Let me check whether there is some correction or not. I think there must be some correction in the question because answers are not matching. Options are not matching actually. This is 0.96. That's correct. And it's 220 root 3 220 kV 20 kilometer line. I think everything is fine. I think everything is fine. 0.5 into 10 to the power minus 4. That's also correct. Angle 90. 0.96 angle 3 degree. Okay, guys, everything is fine. So this value is nearly equal to this answer, because exact answer is not getting, because this is nearly equal to 1. Okay, so answer is Agra. Okay, answer is Agra. So you'll get this. I mean, approximate answer you'll get, because you are not getting the exact answer because it is 0.96. It is nearly equal to 1. So you can say that it's 11 by root 3 almost. Okay, let's come to the next question, guys. The next question on your screen is the ABCD parameter of a 3-phase overhead lines are. These are the ABCD parameter. A is 0.9 angle 0 degree. B is 200 angle 90. C is 0.95 into 10 to the power minus 3. 10 to the power minus 3 angle 90. Okay, this is C. At no load condition, a shunt inductive reactor is connected at the receiving end to limit the receiving end voltage to be equal to sending end voltage. What we are doing is, we have the transmission line whose ABCD parameter are given to us. Let's say this is a system of transmission line. Now, what I need to do is, I need to connect a reactor here, an inductor here. At no load, I need to connect an inductor here such that this voltage become equal to this supply voltage, source voltage. Okay. A shunt inductive reactor is connected at the receiving end of the line to limit the receiving end voltage to be equal to the sending end voltage. What is the ohmic value of this reactor? What is the ohmic value of this reactor? We need to calculate that. Okay. So again, it's a very good question. Let me give you 2 minutes for that. Okay. Let me give you 2 minutes for that. Do it fast, everyone. Tell me the correct answer. It's very simple. Think about it. Try to calculate this. Everyone, tell me the correct answer. Do it fast. How to solve this problem? Do it fast, everyone. Do it fast, everyone. It's a very good question. Okay, so time over. Now it's my turn. We know that no load receiving end voltage is given as Vs by A. No load receiving end voltage is Vs by A. Now, for this network, ABCD is given to us. ABCD, everything is given to us. If I want to connect this reactor, then this no load voltage has to be equal to this supply voltage. It means this A has to be 1. After connecting this reactor, the overall A has to be 1. Now, A of this part, A of this transmission line is given to us. What is the A of this network? I mean, we need to calculate the overall ABCD. So ABCD of this network is given to us. What is the ABCD of this network? So let's calculate the ABCD of this network. Let's assume that its reactance is Z, its ohmic value is Z. What is the ABCD parameter for this? Let's take it like Vs, and this is VR, this is Is, and this is IR. Now we know that Vs equal to VR. We know that Vs equal to VR. For this network, Vs equal to VR, and Is equal to VR by Z. This current is VR by Z plus IR. So how to calculate ABCD of this network? The ABCD of this network is 1, 0, 1 by Z and 1. This is the ABCD of this network. ABCD of this inductive load network. It is connected in shunt. Okay. This is the ABCD of this part only. This part only. We have calculated like this. Okay. Now, in the overall network, if you look at after connecting the shunt reactor, the overall network, what is the ABCD of overall network? Especially the A. Especially the A of the overall network. So the A of overall network is ABCD of this into ABCD of this, because they are in cascade form. So ABCD of this network, which is provided to us, into ABCD of the reactor. Now what will be the overall A if you calculate this value, this into this? So it will become A plus B by Z. This is my new A. A plus B by Z is the new A. You can see that. And this value has to be 1. This value has to be 1. Let's call it A prime. Okay. So this voltage at no load is equal to this voltage divided by A prime of this entire network. And we know that this no load voltage and this sending end voltage are equal. So this A prime has to be 1. It means this value has to be 1. So A plus B by Z, A plus B by Z has to be equal to 1. Okay. I mean the magnitude of this quantity has to be 1. What is A? A is 0.9, angle 0. What is B? B is 200 angle 90. So 200J by B is equal to 1. Take this 0.9 on this side. So it will become 0.1. So B will be equal to 2000J. Oh, sorry, this should be Z, excuse me. So Z will be equal to, B is 200J, okay. Now you can calculate from here Z. So Z will be equal to, you take this will be 0.1, 0.1 will be in the denominator, so Z will be equal to 2000 J. So the ohmic value is 2000. Answer is Bombay, okay. Answer is Bombay. So this was a very simple question, but very interesting question, I hope you understood it, okay. Let's move to the next question. The next question on your screen is this. A source is supplying a load through a two-phase 3-wire transmission. So you can see that this is phase A, this is phase B, and this is the return path. Okay, this is the source, this is the load. Okay, the instantaneous voltage and the current in phase A. This is the voltage in phase A and this is the current in phase A. Similarly, in phase B, this is the instantaneous voltage and this is the instantaneous current. Now what I need to do is the total instantaneous power flowing from the source. How much instantaneous power is flowing from the source? So it's very easy question, guys. Try to solve it. What is the total instantaneous power flowing through the source? We need to calculate that, and options are given like this. So what is the correct option? In this option it is square. It is given as square. Okay. So tell me, guys, which option is correct? Which option is correct? Okay, I think it's visible now. I think it's visible now. Tell me, guys, what is the total instantaneous power supplied from this source? It's very easy. Options, I'll show you on the next screen. Just give me maybe 5 seconds. Okay, options are given like this. 2200 watt, 2200 sine square of this, 4422 sine into cos. Let's calculate the instantaneous power, guys. Let's see which option is correct. So for phase A, the instantaneous power is the product of this voltage and this current. So if I multiply, it will become 2200 sine square 100 pi t. In instantaneous power, we just multiply voltage and current. Instantaneous value of voltage and instantaneous value of current, just multiply them. Okay. Now for phase B, what is the instantaneous power? For phase B, this is the voltage and this is the current, both are in cosine. So again it will be 2200 cos square of 100 pi t. Now what is the total instantaneous power? The total instantaneous power is, this is the total instantaneous power supplied from the source. So if you add them, then sine square plus cos square is 1. Take this 2200 common. Okay, so the answer is 2200 watt. This is the total instantaneous power supplied by the source. So the answer is Agra. Answer is Agra. Okay, I hope it is clear, everyone. Tell me. I hope it is clear. So this was a simple question. You need to calculate the total instantaneous power supplied from the source. So this is the instantaneous power of phase A, this is the instantaneous power of phase B, and you can add them to get the correct answer. Okay, so answer is Agra. So this was the last question, guys, and I hope you enjoyed this session. In the upcoming session, I will take the questions on transmission line, like long transmission line, medium transmission line, and capacitance calculation. Okay, so in the next class, I will take capacitance calculation, lecture on capacitance calculation, and then on long transmission line and medium transmission line, we will take some questions on that. Okay, so I hope you enjoyed. So don't forget to subscribe our channel if you have not subscribed it, and please like the session and press the bell icon so that you get the notification whenever my sessions are live. Okay, so thank you for showing interest in this class. See you in the next class. Next class will be tomorrow at 11 a.m. Okay, so take care guys. Bye.